Aloha! Welcome to this lesson video for multiplying and dividing rational expressions. We want to be able to multiply and divide and then write our answers in simplest form. So, here we go. Just a quick recall of how do we even multiply fractions with regular integers. Just remember you go straight across the top and bottom, multiplying obviously. So 3 times 7 we get 21. 4 times 6 we get 24. There we go. Is this in simplest form though? Does this fraction reduce? It does, because I could divide out a 3. So this equates to 7/8. So with rationals it's kind of backwards. We kind of divide out what they share first and then we go across the top and bottom. And let me show you what I mean. We always want to make sure we factor all of our parts first. So it's very important to be neat and organized. I always like to start at the top left corner. Can I factor an x? Well, no. But can I factor its denominator? Sure I can. They share a 5x, so let me take that out. And I'm left with x minus 4. And the second fraction, numerator, I'm stuck with x minus 4. Nothing to do with that. The denominator, both terms share an x. So if I factor it out, what do I need in here so that when I distribute x, I end up with x squared minus 3x? Well, I need an x minus 3. Okay? So now the fun part, look for like groups. So x minus 4 is the same. We've got these loner x's, if you will. We could do one of two things. We could cross this top x out with this one that's attached to the 5, or we could cross it out with the one in front of that group. Doesn't really matter. I think I'm just going to go with the diagonal. Why not? Okay? So now we crossed out what's shared. Now we're going to go across the top. So wait a second. There's nothing left, so you fill it with a 1. Going across the bottom, I've got that 5x and then that x minus 3. Okay, so this would be my simplified answer after multiplying. So we don't actually multiply like you're used to, but this is what we do for rationals. So let's look at another one. Holy cats! I've got a fraction, but then this guy's not a fraction. Oh no, what am I to do? Well, make it a fraction. Put it over a 1. So then you've got two fractions, and it's just like example A. Okay, so let's be nice and orderly again. First fraction numerator, x squared, can't do anything with it. This denominator though, let me come over here and do some scratch work. I can definitely factor him. How can I? Do they share something? Do all terms share something? Could I factor with an x puzzle, divide and slide? What would it be? Well, because of that 4, it is divide and slide. So here's the process. The first times the last. Okay, so I have x squared minus 5x minus 24. And then from here, this lets me do an x puzzle. What two numbers multiply to negative 24 and add to negative 5? Oh, negative 8 and 3. There you go. So I get x minus 8, x plus 3. Now, don't stop here, though. Don't stop. Divide by the 4. Okay, because this is called divide and slide, so I got to divide somewhere. All right, so we have x minus 2. And then 3/4. If I divide, I get a decimal, so don't do that. Can I reduce that fraction? No, I can't. So then you slide. Slide that bottom up. Okay? So this is actually the denominator of this first fraction in factored form. Okay? X minus 2, can't do anything with that. Now you could keep the parentheses, you could drop them, doesn't really matter. Okay. Now here's the fun part. Look for stuff to cross out. X minus 2's. So what am I left with? X squared on top, 4x plus 3. Now, hey, hold up. Wait a minute. Why can't I divide an x here? You know, cancel out an x. Well, let me tell you. This top x squared means you've got like 2 loner x's. Down here, this x is married with that +3. So they've got a different status. Single versus married, you can't cross them out. So, I stopped there. This guy's a cool one. Let's see. Being neat and orderly, I start at the top of the first one, but I can't do anything with x minus 4. The denominator, I can do a little factoring. It's actually a special x puzzle. We want it to multiply to -9, but there's no middle number, so what do I want it to add to? Well, you want it to add to 0. That's why there's no middle there. So what multiplies to -9 and adds to 0? That would be 3 and -3. Okay, so that would make my groups x plus 3, x minus 3. Okay. 3 minus x, I can't do anything with that. This denominator though, 8x squared minus 32x. I think they both have an x. And they're both divisible by not a 4, but a 8. Go for the biggest. So what would I be left with? Take away his 8. I took away one of his x's. I'd have an x left minus, divide 32 by 8, a 4. But I did take his x away, so it's just a 4. All right, so we're ready for that cool part. I love rationals because I can cross stuff out. X minus 4, it's out of there. Oh, wait a second. Look at this. X minus 3, 3 minus x. Man, can I cross them out? Are they exactly the same? They're just flip-flops, so can I cross them out? Oh, let's talk about it. This x is positive. This x, oh, it's negative. This 3 is negative, but oh, this 3 is positive. Rats, they're just wrong sign. Fear not, there is a cure. Slick little trick here. If you take out a -1, what that will do is just make these guys change their sign. So it really makes the 3 turn negative and the x turn positive. So I'm just gonna write it like this, so then these two groups look exactly the same, and I can do that. Okay, so what am I left with? A -1 on the top, and on the bottom, I've got 8x and that x plus 3. Boom, bada bing, that's it. All right, I have this example D. It's just 3 fractions instead of 2. I think I'm gonna skip ahead for the sake of time and talk about dividing. Now, how do we divide fractions when we're just, like regular integers? Well, we've got this thing, keep, change, flip. And what we do is we keep the first fraction, we change division to multiplication, and we flip the second. And then it's just like multiplication, and we go across the top and get an 8, and go across the bottom and get a 3, and that's it. So we're actually going to use this for our rationals. Keep, change, flip. Keep the first fraction, can't do anything with an x, can't do anything with an x plus 4, but because it's division, I'm going to change it to multiplication and invert this second fraction. So I'm going to look at the bottom first, but again, x plus 4, nothing I can do. X squared, nothing I can do. So cross stuff out, yeah. So what do I got here? I got an x over x squared. Now you might have caught this back here, but in case not, and you're at this point, you've got loner x's here. So what's gonna happen is you're gonna actually cancel this x out with one of the 2 that he had down there. So technically, you've got an x left over in the bottom, but you gotta fill the top with a 1. All right, cool beans. Whoops, let's see. We can buzz through this guy real quick. Factor the numerator with x puzzle. So what 2 numbers multiply to -24? Add to -10. Oh, a -12 and a 2. All right, you might have tried 6 and 4, but it actually won't work with the signs. So it's got to be -12 and a +2. The denominator, they share 3, so factor that out, and you're left with x minus 6. Take a look in the middle, it's division, so we gotta multiply and flip the second fraction. So I'm actually gonna start at the bottom because that's gonna be the new top anyway. And what do these guys share? They share a 2 and an x. So what am I left with? X minus 6 inside. Now look at the new denominator, which was the old top. And I gotta do an X puzzle for that. What multiplies 12, adds to negative 13? What two numbers do it? What? Negative 1 and negative 12. So I should have X minus 1, X minus 12. All right. I'm picking up what you're laying down. So cross out the X minus 12, cross out the X minus 6. Anything else? Do a quick scan. Looks like we've got a 2x, x plus 2 on top, and 3x minus 1 on the bottom. Nothing can go away, so that would be it, folks. Now, usually when you talk about rationals and division, we throw in this complex fractions. And I say the hint for tackling this beast, because it just kind of looks daunting, is to remember this. A fraction bar means division. So it's really asking you to take the top fraction and divide it by the second fraction, which, well, shoot, we've been doing this already. Keep the first fraction, x minus 1 over 5, change because it's division to multiplication, and flip the second guy. Can't do anything with 25. 3x minus 3 though, I can take out a 3 and I'm left with x minus 1. So then, cool part, cross out like stuff. Hey, you know what? This 5, I can cancel it out. Well, actually rather, divide it out. And 25 turns into a regular 5. So what's left on top? A 5. What's left on the bottom? A 3. All right. So that's all it is to complex fractions. It's just realizing that it can be rewritten in this way that we're already used to. Okay. So that's going to finish this lesson video for us. You may also want to view our adding and subtracting rational expressions part 1. And then there is a part 2 as well. So keep learning, guys. I will see you next time.